Hello, family. Welcome to Geography IGCSE, and we're working on earthquakes and volcanoes as the topic that we are on under natural geography. And today we're going to look at the first part where we're going to be looking at the structure of Earth, and we are going to start looking at volcanoes. So you guys, you're in for a treat. You're gonna have a good time. You're going to figure out stuff maybe that you didn't know. Some of you that you did know. If you're a geek like me, maybe you already knew. But you're gonna have a lot of fun today. So let's jump right into it, and then okay. So let's move on. So this is what a volcano will look like on a diagram, right? So we want to look at all of these things and say what are they. So we're going to look at this is the magma chamber. We've already described what magma is, right? So this is what we call the magma chamber, and the magma is here, right? This is the main vent through which the magma erupts to the surface. This is a secondary vent. There can be a smaller vent that creates also a smaller secondary cone. This is the main cone, all of this, right? But it can also be a secondary vent that pops and starts that magma will erupt from, and it will form a secondary cone, a smaller cone here. And this is the crater. So the crater is this bowl-shaped depression at the top of the volcano, and it forms after an eruption. So after an eruption is formed, I'm sure you've seen pictures of a volcano after it is formed, where there's this just bowl-shaped here depression. It's called the crater. And then we have the ash cloud, which is this. It forms when fine, which is very fine, right? Volcanic ash particles are ejected into the atmosphere, right? So these clouds can travel long distances, and then it can also affect air travel and climate, right? So we're looking at issues to do with disrupting air movements, because planes will not be able to see, and it will be having to move through ash, and it's just dangerous, and it also affects the climate. Then let's look at the volcanic bombs. So these are the volcanic bombs that we're looking at here. So I know it's small here, but it's very huge. It can be these black things, the volcanic bombs can be meters in diameter. So these are fragments of molten rocks which are forcefully thrown out during an eruption. So as the eruption is happening, boom, right, and it's exploding. These fragments of molten rock are forcefully thrown out during the eruption, and it cools and solidifies before it actually hits the ground. So boom, this molten rock is thrown into the atmosphere during an eruption, and it then cools. By the time it gets to the ground, it would have solidified. So these are between 60 millimeters, which is just above half a meter. No, sorry, just above 60 millimeters makes it what, 6 centimeters, right? And then they can be as big also as 5 meters in diameter. So this thing, if this thing hits you, my brother, my sister, you are gonna. Anyway, that was the Nigerian in me speaking ish. But anyway, I'm bullish. I'm joking. So let's look at the pyroclastic flow. This is what we call the pyroclastic flow. This is what we call the pyroclastic flow. What is it? It is a deadly mixture of hot gases and ash and rock fragments that rushes down the volcano slopes at high speeds. It can devastate anything in its path. The average speed is about 100 kilometers per hour, but it can move up to 700 kilometers per hour. So it's really crazy, really crazy. So we've talked about the main vent. It is the central tube through the volcano, and it connects the surface to the magma chamber, allowing the magma to rise during eruption. So it connects the surface here to the magma chamber. This is the main vent, right? Then we have layers of ash. So over time, volcanic eruptions deposit layers of ash. So we're talking about, you see all of this ash that is coming that is being ejected into the atmosphere. When it also falls, it forms layers of ash. So each time it's ejected, ash falls on the volcano cone, right? And this deposition of ash forms layers of what? Of ash. So over time, volcanic eruptions deposit layers of ash and other materials on the volcano's slopes here, right? And these layers build up and contribute to the shape of the volcano. So we talked about magma chamber, and we said it's a large underground pool of molten rock. So this is the magma chamber, and it's typically located or usually located in the Earth's crust. Within the Earth's crust, the magma comes from the mantle and collects in this chamber. Right? Then the secondary cone, sometimes we talked about it, sometimes eruptions from other vents on the volcano, the flank side, which is the side, the flank, which is the side, lead to the formation of a smaller cone called a secondary cone, right? Sometimes eruptions through the secondary vents will form a secondary cone here. Then we have what are called layers, or if you are like me, when I was in high school, I'd say lahars because I wanted to make sure I get the spelling correct. So when volcanoes erupt, snow and ice on the peak melts, right? And then that snow and ice combines with the ash, and this creates fast-moving mud flows or layers. And these mud flows can devastate, can destroy houses, can destroy vegetation and everything. So you can see these mud flows. These are the layers that we're talking about. And when they flow and they're fast moving and they're mud flows, that can destroy things, right? Then earthquakes. So as the magma is rising to the surface through the vents in the volcano, through the vents in the volcano, it increases pressure on the Earth's crust, right? Leading to earth tremors, which means the sudden shaking of the what? Of the ground. So that so due to the type of lava that is erupted, the formation of volcanoes will vary. So due to the type of lava that is coming out, we have different types of volcanoes that we have two types. The first one is the composite or the stratovolcanoes, right? So this one is tall, right? And it is steep-sided. It is steep-sided. You can see the sides are steep, right? It is more explosive eruptions. Boom! It's formed from alternating layers of ash and lava, right? So we have the layer of ash here, and then as the lava erupts, it also erupts on top. So pretty much all volcanoes are like this. So it's a layer of ash here, and then on top we have a layer of lava, right? And then a layer of ash, a layer of lava, right? So when the ash boom, it's executing the atmosphere, it falls onto the slopes, and then the lava also comes, it flows because it's being erupted from the what? From the magma. So it tends to form on convergent or what are called destructive plate boundaries. We'll talk about this. So just put a pin on it, and then you get it on plate tectonics, what it means. But basically, it's when tectonic plates are moving towards each other. Then we have what are called shield volcanoes. If you can see, the sides are gently sloping, so it doesn't really go high, but the sides are gently sloping, right? And the lava is thin and it's runny. So the lava is really thin and it's runny. Something is runny, it's like water is very runny, right? Because it's thin. They are less explosive, means they're gentle. They tend to form on divergent or constructive plate boundaries or hotspots, right? So divergent or constructive plate boundaries are where tectonic plates are moving away from each other. Or they can also form on what are called hotspots. And then the eruptions are frequent. So we'll discuss these last 2 points in our other videos. So you feel free to check the other videos, and I'm sure it would do you a lot of good. And then volcanoes can be active, which means a volcano that has recently erupted and is likely to erupt again. Or a volcano can be dormant, which means it has erupted in the last 2,000 years and may possibly erupt again. Or they can be extinct, which means they show no evidence of eruption in historic times, and there is no evidence of a magma reservoir or a magma chamber with the magma. So it's active, which means it has erupted recently and it's likely to happen again. Dormant, erupted in the last 2,000 years and may possibly erupt again. And extinct, shows no evidence in historic times. So let me just rush through. Let's look at Mount Kilimanjaro, right? It is the highest peak, so you can go ahead and read about Mount Kilimanjaro here. It shows you a dormant volcano. Then we look at Mount Eglon here. It's an extinct volcano. This Mount Kilimanjaro is in Tanzania. Then this one is also in East Africa. And then this one also is in the Democratic Republic of Congo. This is an active volcano at Mount Nyamuragira. I think we are done for now. This is Des, and this is the School of Chaos. Goodbye. See you in the next class. Don't forget to tell your friend, and to get everyone to just sign up. Once you watch this and you're just serious about this, please pause and read this. But you don't need anything else. Once you just watch these things, you're good to go. You can literally watch this, revise your past papers, and you're good for the exam. So, this is Des. I'm signing out. Peace.